Assalamualaikum warahmatullahi wabarakatuh, and good morning. My name is Aiman Jahari, and today I will present about my final year project. My final year project title is Analysis of Power Distribution System of Automatic Platform Gate in MRT Line 2. Automatic Platform Gate is a barrier that we install at the platform, either in elevated station or in underground station. It has their own power distribution system to ensure the power energy can keep flow to the each component while protecting the equipment from the surge and sequencing of power allocation. This study is to aim and to investigate on how the APG and their component can be powered in any situation, and after that we can calculate how many power load of APG. The study will collect data from the literature, observation at the site, and also from the partial acceptance test which is done to the all station in MRT line 2. So after that we can produce a MATLAB simulation. For the introduction, this is the APG power distribution system. It has two core components, which is drive power cabinet and control power cabinet. Drive power cabinet will receive 400 AC and will turn it into 110 volt DC. Then it will supply the power to the door and also to the control power cabinet. Then the control power cabinet will turn it into 24 volt DC to supply the power for control power. The problem statement is the power distribution for APG if any failure happen, and also the power load value in the APG system. The objective of the study is to determine the power distribution parameter and system requirement for APG for MRT line 2. The second objective is to develop a simulation model for power distribution system to powering up the APG based on partial acceptance test. And the third objective is to analyze the performance of APG in terms of transmission, distribution and power loading system. This is my methodology of my study. First, we develop a assumption and input data. Then we do a data collection from the literature and also from the observation. Then we will done a partial acceptance test, which is test that we done to make sure all APG in acceptable range. From the partial acceptance test, we can get a value of the output voltage, and we can see if our simulation is acceptable or not. Then we will develop model and we do a circuit simulation, and then we will get the output voltage. If the output voltage in acceptable range, we will do a result discussion and do conclusion. If the output is not in acceptable range, we will do the parameter and component checking, and we will redevelop model. The parameter for the simulation is 400 volt AC for the input. The frequency is 50 Hz. The max current is 50 ampere per PDU. The minimum power is 7000 watts, and the output for drive power must between 104.5 watt to 115 and control power output voltage must between 22.8 to 25.2. This is my simulation schematic design. So this is to supply power, which mean they supply 400 AC to the PDU, 400 AC to PDU1 and 400 AC to PDU2, and between this PDU there are ML, which is breaker that connecting between two PDU. And in one PDU there are two module, AC-DC module S1 and AC module 2, and PDU 2, AC module 2 and AC module 3 and AC module 4. And when we stimulate, we will get a result at this area and this area. This area mean drive power output voltage, and this area is control output voltage. So to analyze the APG power transmission and distribution, we will conduct a 4 situation. The situation 1 is power on PDU1 and PDU2, power on PDU2 and PDU2 is power off, power off PDU1 and PDU2 is power on, and pull out one set of any AC-DC module. And for the to calculate the APG system power loading, we will use P equal to IV for drive power load and for control power load, we will use power rating of motor divided by efficiency of module. So this is result for the simulation of APG power transmission and distribution analysis. This is condition 1, condition 2, condition 3, and condition 4. So for the condition 1, the output voltage for drive power is 115 and the output voltage is 24.15. For the condition 2, the output voltage for drive power is 114 and the output voltage is 23.78. For the condition 3, the output voltage is 114.7 and the output voltage is 23.78. And for the condition 4, the output voltage for drive power is 115.1 and the output voltage is 24.15. If we see for all these 4 conditions, the output voltage is in the acceptable range, which is for the output voltage of drive power 104.5 voltage to 150.5 voltage, and for the control output voltage is in between 22.8 voltage to 35.2 voltage. This is happen because the redundancy design that implement in the APG power distribution system. When we observe this circuit, we can see if we cut the power from one PDU, either is PDU1 or PDU2, the other PDU will supply drive power to all APG. It means the APG can be operated if we cut the power from one PDU. So when it also happen when we pull out the one set of AC-DC module, it means the other module will cover the other failure module, so the APG will get the power supply and can operate for the operation. After that, for the APG power load analysis, we find that the maximum drive power output voltage is 115.1. We will divide by 2.5 ampere, which is the maximum current for one doorway, and then we will divide by 16 because there are 16 door. For the one station, there are two platform, and we will times by 2, and we will get a 9,208 watt for drive power, drive load power. For the control power, we will divide a 600 with a 0.9 because the efficiency of module is 0.93, and we will get a 666.7 watts. So we will plus with 400 watt because the 400 watt it comes from the MMS, and MMS has their one industrial computer and one LCD display. So we will time, the total is 1006.7 watts. So in the APG power loading system, the drive power loading is 909,208 watts, and the power loading for APC is 1006.7 watts. So we will plus, we will get 10,308 watt. This means that's the power that required for powering up the APG. For the conclusion, the power distribution system for APG has been obtained based on the observation on APG PhD cabinet and from the partial acceptance test. Then after that, we managed to produce a simulation from the MATLAB Simulink. From that, we can identify on how APG PhD power distribution system work based on 4 modes or condition, which is in partial acceptance test. When we perform the simulation according to the set of condition or mode, the output voltage result for ADC module and DC-DC module show that it not run away from the accepted value. It means the Jahari design is working 100% to prevent APG from failure. It means the PDU1, when the PDU1 is breakdown, PDU2 will supply drive power to all APG station. When PDU2 is breakdown, PDU1 will supply drive power to all APG station. Then from the output value, we can calculate the drive power loading, and the load control will show the amount of power that need to produce for APG PLC system to function. That's all about my project. Thank you for hearing my presentation. Any question, you can ask me in the comment below. Thank you.